Hi, everyone. My name is Vianney JOUHET. I'm really happy to give this talk today. I would like to thank the organizer for inviting me to present this topic. We will be speaking about clinical data warehouse. So I'm a medical doctor in public health, specialized in medical informatics, and I'm responsible of setting up and making work the clinical data warehouse of Bordeaux University Hospital. I'm also involved in a research team in the BPH INSERM Center in Bordeaux. Today, so we will be speaking about hospital clinical data warehouse, but I would like to highlight some issues about the necessity to be able to have some local usage for medical doctors in the hospital, but also to be able to integrate and to be involved in the federated networks. So let me start now, if it works. Okay, good. So some backgrounds. So I think you all know that, but it's always important to say it again and again. For now, we have more and more health data that are available, that are produced in a real life settings for taking care of patients, and methods and computation capabilities have been developed. So there is a growing interest for years now in reusing this data for other purpose than just taking care of patients. And it introduced the important concept of secondary use of health data. For this reason, the FDA introduced another concept, which is real-world data. And real-world data is data relating to patient health status that are or delivery of healthcare that are routinely collected from variety of sources. So it includes a lot of different data. Within this data, one axis is important and involves clinical data warehouse, which is named EHR for electronic health record, and it's often clinical data that are present inside hospitals. There is a lot of other possible data sources, but I won't be talking about them for now. I'm just concentrating about with clinical data and EHR within hospital. From this real-world data, you may want to produce what the FDA calls the real-world evidence. So it's just to make the contrast with research data that are specifically produced for research purpose and for creating new insights about a topic. And by opposition, the real-world data and real-world evidence are built on top of data that are collected for healthcare purpose and that are reused in order to make new evidence. So when you are in a hospital and you want to reuse the data, the really well-known issue is the hospital data silos. So the idea is, because you are within a single hospital, even if you are within a single hospital, there are multiple applications that will be used by different specialties in the medical settings in order to collect data. For instance, there will be an application for the images, an application for clinical data, an application for biology, and so on. Just to give you an example, in Bordeaux University Hospital, there is more than 100 applications that are deployed in order to collect healthcare information, depending on the medical doctors. And because there is a lot of applications, there is a lot of databases that are separated. And within these databases, there are a lot of different tables. So there is a huge complexity. And in fact, if you want to query this data in order to identify patient given some symptoms, signs, or biological results, and combining all these items within a single query, you will face one first issue, which is the query complexity. The query you will have to build will have to query a lot of tables. It will be complex, and it won't be possible for a medical doctor to build this kind of query. It will be it has to be built by a specialist in databases. The other main issue is the fact that the databases are optimized for primary use, meaning taking care of patients. So their main goal is to be able to collect information and to give insight about a single patient. These databases are not made in order to enable retrieving multiple patients, hundreds or thousands of patients, depending on multiple criteria. They are not built for that. So you will face another issue, which is execution time. And just imagine if you want to give a medical doctor a tool in which he could build a query and then have results about his patient. If he has to wait for hours, he will do the query once. Maybe if he's really motivated, he will do it 2 times, but then he will say, okay, your tool is useless because I want a result in seconds. I don't want to wait hours in order to have my result. I want to find my patient as I want because I don't have time for in order to wait for hours. So we name that the data silos, meaning that the data are separated in different databases and the fact that you cannot query them easily. The main way of tackling these issues is setting up a clinical data warehouse. So clinical data warehouse is really an old tool, something that exists for long now. It's used in the clinical setting, so in the context of healthcare, but it has been used in all the business intelligence systems. And the idea, it's pretty easy to understand. You have your information system on the left part of this slide, which is complex, a lot of databases, the data silos, and then you will just extract the data from the information system. You will transform them and load them. We call that the ETL for extract, transform, and load. And you will load this data into a single database, which is optimized in order to perform query. It's not made in order to collect data, but it's optimized in order to perform query and transversal query across the entire data set. When you are in the clinical data warehouse, your query has to be really fast, and also all the data are integrated together. So the query pattern, the way you will build your query, will be always the same. So the data will be really easier to reuse, and then you can implement as many use cases as you want, such as data visualization, strategic analysis, and research, studies, evaluation in the healthcare setting, and other use cases, as much as you want, if your clinical data warehouse is adapted enough. So, as you can imagine, the real complexity is in the extract, transform, and load part. You have to build a lot of extraction from a lot of databases, but then if you have your data warehouse, you can start reusing the data. Another issue that you have to keep in mind is the fact that health data are sensitive data. So when you want to reuse this data for other purposes than only healthcare, it's regulated by GDPR in Europe. And this implies some kind of important concepts such as minimization, meaning that you have to pseudonymize your data, remove everything that could identify the patient directly. You have to be transparent, and you have to implement transparency so that the patients that are concerned by this data are aware of what you are doing with this data, and that they don't have any opposition to the fact that you implement some kind of use cases. And the main issue about this sensitive data is the fact that you cannot share pseudonymized data or individual data easily, meaning that the only data that are really easy to share is anonymized data, because if it's anonymized, it means that you cannot re-identify anymore the patient, meaning that there is no way of identifying the individual person, neither using direct identifiers, but also indirectly by combining the data. So in fact, anonymized data in the healthcare setting are aggregated data, meaning the number of patients having some kind of symptoms or stuff like that, but not individual data. And this is really a big issue, because if you want to share data across multiple institutions, you can do it. It's not infeasible, but you will have to to build a complex project and have a lot of authorization in regard with the GDPR, which may take a lot of time. In order to address this issue, it has been built federated networks. The idea of federated networks is the fact that you have your data locally in your clinical data warehouse, the data stays in your hospital, in your clinical data warehouse. You will just execute scripts on top of this data. And what you will share across the network will be only aggregated data, because these data are aggregated, meaning that it's just number of or means or median and stuff like that. Meaning that because it's anonymized, there is no regulation anymore about data privacy, because there is no risk that you can re-identify patients. So when you implement a network, you can just send your script to the institution that will execute it and send you back a file that will contain number of patients and so on. And you will be able to just execute some kind of meta-analysis. And you can, doing stuff like that, you can have studies that will rely on millions of patients and on billions of EHRs, which could be really interesting. So it often poses methodological questions, but you can implement them and it can go really fast. So this is really important to be able to set up federated networks. Just a point, an important point, when I'm talking about federated networks, I'm not talking about federated learning, which is not exactly the same thing, but of course, federated learning will rely on federated networks of data. But you can also implement other stuff that learning with this data, you can implement just producing some kind of insights and research projects that are a more classical way of doing statistics. So in Bordeaux University Hospital, we have a clinical data warehouse that is implemented. It loads a large part of the electronic health record for the patient that came to the hospital since 2010. The idea of this slide is just to show you the numbers that you can find within a clinical data warehouse. Just imagine that you have 2 million patients, 21 million venues, and for these patients and these venues to the hospital, you will have billions of observation, 3 billion here in Bordeaux clinical data warehouse, but there is a lot of clinical data warehouse everywhere in France, and the numbers are the same. So in each data warehouse, you will have this kind of numbers of patient venues and observations. What is particular in Bordeaux University Hospital is that we really integrated the entire application. So we have nearly a complete view about the patient. Two data sources are missing in this slide. One is the images, and the other one is the ICU data, but we are working on it. So in Bordeaux, I would say, okay, we are pretty happy with that. We have a clinical data warehouse that is able to handle data silos. So in this schema, you can see we have the production, then we will load the data in we will replicate the data in a first stage, and then we will integrate the data into the clinical data warehouse every day. So we have just 24-hour delay between the data collection in the healthcare system and the data in the clinical data warehouse. And because we need to have information about the patient death, even if it's not within the hospital, it's really important to have this information. We can link this data with the open data from the death database in France. And then we could complete our death record within our clinical data warehouse, which is really important because it completes 17% of the deaths for the patient. So if we don't do that, we only have 30% of the deaths just because patient didn't die inside the hospital. When we have this kind of settings, we could say we are pretty happy. We have a clinical data warehouse that is fit for use, meaning that the data are integrated, available, and up to date. But we can ask the question, is fit for use enough? And if we look to the settings I'm just showing you, we have remaining challenges. I told you about data silos, but we also have semantic silos. Because just imagine, because we integrate together multiple distinct applications, each application will have its own data dictionary. And if I want to put all these data together, I need to describe them with a data dictionary. So I will end up with a high dimension dictionary, which is more than 2 million entries that represent more than 100,000, something like that, variables. And moreover, these data are heterogeneous and multimodal. I could find within my clinical data warehouse coded values, numerical values, structured information, free text, images, molecular data, and so on. And these information are also really redundant, and there is some kind of incoherence or inconsistencies within the data. This means that if I want an end user to be able to query the data warehouse, he needs to know every variables that are available. Otherwise, he will miss information. And the size of the dictionary is not humanly understandable. So there is still a challenge. The other challenge and the other issue that is still there is because I want my clinical data warehouse to be able to serve the local use cases, but also to be able to answer the use cases that will be within a network, I have to adapt my data for this network. For examples, in Europe, there is two big networks that exist. IDEN, which is set up at the European level, and the Darwin EU network that is set up by the European Medicine Agency, and that wants to be able to query data from hospitals and medical administrative database and so on. And these two networks are based on the specific clinical data warehouse system, which is called OMOP, which is not the system of the Bordeaux University Hospital. And within this system, we need to do the syntactic integration, meaning putting the data in the right data model, but we also need to do the semantic integration, meaning that we need to map our local terminologies to standardized terminologies so that we have the same vocabulary and we speak the same vocabulary. And moreover, in these networks, we need data quality. We need to evaluate the data quality to just give some kind of insurance for our partners that we have data that are qualitative enough to answer a specific use case, and standardization. The data need to be stable. We don't want this data to be changed every day, so it's not compatible with the everyday load of the clinical data warehouse, because we want the result to be reproducible. As you can see, when you think about the fit for use purpose, and when you think about what should be a good clinical data warehouse, we face heterogeneous users and use case. For instance, locally, we could have healthcare professionals that may want to use the data. We could also have researchers that are not healthcare professionals, or data scientists, experts in analyzing data or training machine learning algorithms, for instance, that would want to use this data. And all these users will need different workspaces. For instance, human-machine interaction for healthcare professionals, so that they can just query the data and navigate within them. Programmatic access or command line execution for researchers or data scientists, which is really different in the way you will query the data, you will access the data. And also there are heterogeneous needs. For instance, when you are on a local usage, you will want to have detailed data that are really similar to the data you will have in the information system, so that the healthcare professional will be able to query them easily because they will query what they know. And at the opposite, in a federated network, you will need standardized data. And when you standardize the data, you will lose some kind of granularity. You will need to just group information or map them to something that is less precise than what you had in your clinical data warehouse. So this is really contradictory. There is too much heterogeneity within the data, within the users, within the use cases, within the needs. For this reason, the challenge to tackle is to be able to go from fit for use, so the fact that the data are integrated, available, and valid, to fit for purpose. I have a use case. Are my data okay for the purpose of implementing this use case? And for that, we need more than just integrating the data into a centralized database. We need relevant tools, relevant data, being able to evaluate the quality of the data. And the idea here is to be able to address the heterogeneous users and use cases and the heterogeneous needs. In fact, we want a clinical data warehouse that could adapt to any kind of question you would ask, or that would be able to say, I cannot answer the question you have because I don't have the qualitative data or the relevant data to be able to answer this question. So my point here is just to show you how we are trying to address these issues. Of course, at the end of the presentation, I will also show you that it's not a finished work. So don't believe at this point that I will say I have the solution, because this is still a research topic. But I will just present and explain how we are trying and what approaches we are proposing in order to be able to do that. So we start from a fit-for-use clinical data warehouse. It's just the slide that I showed you before. And first, we want to set up a data warehouse that is fit for purpose for the local usages. And just to be able to do that, we need to implement a lot of different parts of the information system for the clinical data warehouse. The first one is the metadata integration. We need to build systems that will help users to navigate within the dictionaries because of the size of the dictionaries. The second step we will have to do is to implement workspaces that are adapted to the need of the users. So there is two kind of things that are important in this part. The first one is implementing human-machine interaction systems that will help users that are not specialized in data, but are healthcare professionals or researchers to access tools that will be user-friendly and easy to use to navigate and build hypotheses and stuff like that, but also implement systems that will enable programmatic access to the database. And below in this slide, there is also something that is really important. You need to implement fast query-able systems. So in our setting, we use Elasticsearch, but there are other examples with other clinical data warehouse that will use other databases. But we've been working on it because we identified that our database, that was a PostgreSQL database at the beginning, was containing with 3 billion observations and a lot of free text. We were not able to query this database within seconds. So we had to adapt our system so that it's more reactive. And the third thing that is really important, it's not only technique. In order to implement a fit-for-purpose clinical data warehouse, you have to organize the transparency and the confidence between the actors. So about transparency and confidence between the actors, our main driving principles were first, autonomize the end users. The idea here is just do it yourself. So this principle is really important because you don't want the clinical data warehouse team to be involved in every project that involves the clinical data warehouse. You want the users to have tools that enable them to implement their own use cases as they want and don't asking something to the clinical data warehouse team. So we just provide support if necessary, but the tools are available to the medical community within the hospital. And this is something really important. Otherwise, you just give the impression that you centralize the data and that, for instance, Vianney JOUHET will just do all his publication because he has a lot of data. And this is exactly the opposite that we want to do. We want the data to be used by more and more end users, and that it produces more and more knowledge about healthcare and health in general. The second driving principle is to standardize the data access workflow and to make it efficient. Just imagine if you have a tool that can answer your question in seconds, but you have to wait a year to be able to access any kind of data because you have too much regulations and it's too complex, too much document to provide, and you won't be able to set up any project. So the idea here is to standardize the data access workflow, integrate it directly within the tools, and also build an organization that will provide an IRB answer in 15 days, less than a month. This is really important because this is really part of the fact that the healthcare professional will accept that the clinical data warehouse will exist and that they will want to implement their own use cases. And also for transparency, we have a transparency portal and a way of informing the patients and the healthcare professional about the clinical data warehouse. But transparency is still a topic that has to be addressed at the national levels. It's not easy to inform correctly and to be sure that everyone is informed about what is done with this data. The second part is adapting the tool. So I won't dive deeply into the technical part of it, just the stuff that are important. Optimizing the query execution time. This is really important so that you have tools that are really reactive and that end user can interact fast with the data. Provide the tools that are secured and adapted to the different needs. Human-machine interaction and user-friendly tools, programmatic access, and also build tools for exploring the dictionaries. So we have an approach based on graph databases, build a search engine and metadata integration processes, but I don't want to dive in too much detail about that. Just at the end of the presentation, I just explained that this is still an ongoing work and it's not perfect yet, but it's better than it was at the beginning. So my point is just to emphasize that because we've been building these tools that are adapted, we just made this available for local users in our hospitals. And in less than a year, we have around 200 projects that have been started and more than 500 users. And these projects are built by 100 of different principal investigators. So we can see that the hospital community and the medical community within the hospital just took these tools and started building projects. Of course, inside this project, some are really well-working projects and some are just more difficult, and people are just, we have to still build the tool with them so that they can do their project. And all these projects are built in autonomy by the end users. For us, this is really a result that is really important because our main goal at the beginning was to build a tool that will be available for end users and with which they will be able to implement their own use cases autonomously. So some projects started earlier, but in fact, we started recruitment of users and communicating about the clinical data warehouse for healthcare professionals at the beginning of 2024. And we are pretty happy with the fact that the project started pretty fast. So now we are pretty happy for the local usage. We have an implementation that provides a clinical data warehouse, on top of it, tools for the dictionaries, and on top of it, tools for accessing the data with a good organization. But still, we have to be able to address the topic of federated network. And to be able to address this topic, we have one huge issue, which is the semantic integration. So just imagine we have 2 millions of data dictionary entry, and we need to map them to standardized terminology. So it's not humanly feasible. We need to implement algorithm for that. So we have to do mappings, just saying that some kind of biological results are mapped to specific low ink, which is standardized terminology codes. And there is a lot of possible mappings. The idea here is to be able to do these mappings, to be able to integrate international standards, such as the networks I presented you. And for that, we explored multiple methods. Some of them are working, are not working. Using morphosyntactic, meaning that we mapped using the labels of the data entries, but sometimes we need languages like English to French translation. We can use also the structural approaches, which means that we use the hierarchical part of the terminologies and the hierarchical part of the local terminologies to try to find similar concepts that we would like to map. And also we could use instance-based approaches. The idea here is, for instance, for biological results to compare the distribution of the results across different systems to be able to identify distributions that would be the same. But when you do this kind of approaches using instance-based data, because you access individual data, you have to take into account the privacy part. So you have to be careful about that. If you want more detail about all this approach, I just put some kind of examples in publications that have been produced before. So with this approach of mapping the data and setting up the specific part of the clinical data warehouse for the Federated network, we were able to integrate 3 networks. One was the 4C, which has a specific data model. It was developed specifically during the COVID-19 pandemics. And the Bordeaux University Hospital, but also in France, the APHP in Paris. These 2 hospitals were able to share the first results in less than a month, meaning that we were able to map our data, which were in our specific data warehouse for local usage, to the standardized data that the 4C consortium wanted to have, and we were able to execute the script and produce aggregated data. On the other hand, we worked on integrating 2 OMOP standardized federated network. The first one is the EDEN network. I talked to you about this network. And the second one is the Darwin EU network. So Bordeaux University Hospital is the first hospital in France that was certified by EDEN, meaning that we have the data quality and the data standardization that is at the level that the EDEN network wants for secondary use. And we are also the only hospital in France that is able to, that has been integrated the Darwin EU network. And we've been involved in 14 studies for now, over 13, sorry. Meaning that our specific clinical data warehouse for the federated network is able to adapt to different networks, and also we have an organization that enables our involvement in the studies. That is something that is really positive from our point of view. Just to say that, okay, I was just presenting to you some kind of topic that we try to address to be able to have a fit for purpose clinical data warehouse, but still, we could ask, is it enough? And in fact, there are a lot of remaining black boxes that are still there and that we need to address. It's not enough. I would not say that the setting we have now is just the end of the road, and for now everything is resolved and there is no research to be made or adaptation to be made and to be done. The main topic to be addressed is really the black boxes. In fact, when you have 2 million dimension data dictionaries with 2 million entries, it's not possible for a human to be able to address this dictionary. So doing that, knowing that, you know that people that reuse the data will only use the data they know or the data they find. And for this reason, they may only include patients that they are able to find, and they may miss relevant data, for instance, relevant patient for a given use case or relevant information for a given patient for a given use case. This could lead to usage of some kind of available data. We call that the data graveyard. Maybe there are some data that are within the clinical data warehouse that are really relevant, but that never used because the people don't know that they exist, even if it's within the dictionary. Also, because we have multimodal heterogeneous data, we have to implement some kind of machine learning algorithm, for instance, for extraction of information from text or stuff like that. And for now, a lot of deep learning algorithm or artificial intelligence algorithm that will handle this kind of modalities will have lack of explainability. So we have to be careful with this kind of algorithm. And therefore, we could ask, what are really the evidence level of the results that are produced based on this data? If I miss some relevant patient, I may create some bias, for instance. And also, still, we could ask, can we identify and handle properly these blood losses? And this is still work to be done. So I don't have any solution for now. This is why I will just conclude saying that remember that the main goal is promote secondary use of data. To promote the secondary use of data, you have to enable the usage locally for the local end users, such as healthcare professionals, but you have also to provide access to other users that are outside the hospital to this data, which is really important. But at the opposite, you need to you need to be careful about data privacy. And also because you want to give this kind of access, you have to integrate a federated network, because in the federated network will just help the usage of the data. So if you want to address this main goal, you have to build fit for purpose clinical data warehouse, which means more than just putting the data all together. It means building tools that are adapted to the local usage, but also specialized for federated network. And a point that I didn't highlight in my presentation, but I want just to explain that now, because this is really important. The only way to implement federated network usage within our clinical data warehouse, it's not the only way, but it is the only way we found for now, is just to build specialized data marts, meaning that you will copy the data into specialized data models that are specifically dedicated to the network that you want to implement. And we have to do that because we need stable data, we need standardized data. So we use the fine-grained data that we have for the local usage. And also, for instance, the HOMOP common data model, which is implemented for the Darwin EU, is different from the 4C data model, which is implemented for the COVID-19. And another conclusion that is really important is that there is still work to be done, meaning that the Bordeaux University Hospital clinical data warehouse is far from perfect. I could speak for hours about the issue we find in the data, about users that are not satisfied with the tools and that the progress we have to make. Still, we are happy that it is used and that we can integrate this federated network, but the fact that still work needs to be done means that people involved in this kind of project have worked, I think, for years for now. And just to finish, I would like to say that you cannot build clinical data warehouse if you don't have a team. So just to thank all the people that are working with me on these topics locally in Bordeaux University Hospital. If you have any question, I will try to do my best to answer.